Hi, everybody. I've been asked to show how to work this problem. This is problem 4 of test 7 of Electrical Engineering 331. And so I wanted to just make a quick video and see how to do that. So, as we have said on these kinds of problems, the first step is to find the homogeneous solution for the left-hand side. So we'll say homogeneous solution and so we'll have the left-hand side. Then, and we're going to denote the homogeneous solution as usual by y sub h. So dyh dt plus 3yh of t is equal to 0, since it's the homogeneous solution. Because we, obviously if it's the homogeneous solution, then it's the solution to the homogeneous equation, which means we have 0 on the right-hand side. And so, as usual, then we know that we will assume a solution of the form yh equals ce to the pt. And when we substitute that into this equation, we will end up finding p plus 3 is equal to 0. And therefore, yh of t is ce to the minus 3t, because of course this means that p equals negative 3. Okay, so that's the end of the first step. Now in step 2, we set h hat of t equal to yh of t times u of t. Okay? And so h hat of t is equal to ce to the minus 3t u of t. And how do we find c? We substitute h hat of t into what equation? Well, it's our original system equation on the left, dy dt plus 3y of t. So in this case, dh hat dt plus 3h hat of t. So we stick in h hat for y on the left, but on the right we just put delta of t. So in other words, h hat of t is the impulse response of the associated system dy dt plus 3y of t equals x of t. This is an important point. Compare that system equation with the one we have at the beginning. You see that the system equation of this associated system that we have down here is exactly the same as the system equation of the original system on the left-hand side. But on the right-hand side, instead of having all this complicated expression dx dt minus 3x of t, we simply have x of t. So the strategy on these problems is find, so this is what I'm calling the associated system. Associated system, okay? I just want to emphasize that our strategy is, on these problems, find the impulse response of the associated system first. It's simpler. And then you can find the impulse response of the original system. Okay, so as I said, then here is the equation that we want to look at, because we're going to stick in h hat for y, since h hat is the impulse response of this associated system, we will stick in h hat for y, and we will stick in the impulse for x. So that's where this equation up here comes from. So let's go ahead and plug in and see what happens. So we have d dt of h hat, which is ce to the minus 3t u of t, plus 3h hat, so plus 3 times ce to the minus 3t u of t, equals delta of t. Okay, so when we take that derivative right here, we're going to have to use the product rule, and we have ce to the minus 3t du dt plus, minus 3c to the 3ce to the minus 3t u of t. We get that from using the taking the derivative using the product rule, and then the next term just is 3ce to the minus 3t u of t equals delta of t. Now, what do we do with this? Well, remember that du dt here is delta of t, so this is 3e to the minus 3t delta of t. And then notice that the next two terms cancel. Remember that we said in this process we always look for cancellation to occur at this point, and here you see it right here. Those two terms cancel out. And so we have this. Now remember, on the left-hand side, we said that f of t times delta of t is the same thing as f of 0 times delta of t. So if we think of, in this case, 3e to the minus 3t playing the role of f of t, then f of 0 would be 3e to the 0, which is 3 times 1, which is 3. So we have 3, oh, and sorry, I've left out here, oh, actually, I see. This shouldn't be, made a little error here. This shouldn't be 3e. This should be ce. See, it's c. Okay, so that should be ce to the minus 3t delta of t. Okay, so so again, if we think of f of t as being ce to the minus 3t, then f of 0 would be ce to the 0, or c times 1, which is c. So we have c delta of t equals delta of t, and therefore c is equal to 1. So h hat of t, plugging in 1 for c, h hat of t is equal to, you can see up here, it's just e to the minus 3t u of t. And again, this is the impulse response of the associated system. And now to get the impulse response of the original system, remember again, I'm going to just stress one more time, the associated system is right here. It has x of t on the right, but in the original system, we have dx dt minus 3x of t. So we have the derivative of what's on the right in this equation, and then minus 3 times what's on the right. So that tells us then that h of t is equal to the derivative of h hat of t minus 3 h hat. So it's just, we're going to have the same equation, same kind of equation that we have right there. The derivative minus 3 times the function. And so that's the same thing we'll have here. The derivative of h hat minus 3 times the function itself. So h of t, to finish up, h of t will be equal to d dt of e to the minus 3t u of t minus 3e to the minus 3t u of t. And so this will give us what? Okay, we use the product rule. We'll have e to the minus 3t times delta of t minus 3e to the minus 3t u of t minus 3e to the minus 3t u of t. And so we finally get, simplifying as we did above, we'll just get delta of t here minus 6e to the minus 3t u of t. That is the impulse response of the original system. And that is, you can see that's answer C. And let me just say one last thing. If you take this function that we have just found, this is the impulse response, or we're claiming that that's the impulse response of the original system. And so if you want to check it, just come up here to the original system, way up here at the top. Since we're claiming that that function is the impulse response to this system, well, check it by just plugging in that h for y and plug in the delta function for x and see if it satisfies that equation. Because it certainly should. If that's the impulse response, that's saying that when we say that's the impulse response, that's what we mean, is that that's the value that y assumes when x has the value of the impulse function. So just plug it in and you will see that sure enough, this function right here, of course, is repeated right here, but that function, sure enough, if you plug it in up here for y and plug in the delta function for x, it will indeed work. So that is how we work problem 4 on test 7.